Alright, so in the last example we discussed how sometimes there are no solutions to these systems of equations, that there's just no possible way that these solutions will ever have these conditions that can both be met, and we may be able to meet one condition but not the other, or neither condition, and so there are times when that happens. But I do want to show you what it looks like when they actually do work out like they're supposed to when we have a solution. So with this, we could spot that this is very easily already set up to be a substitution method, but let's say that you don't remember how to do substitution method one day, and so you do remember elimination method, so that's what we're going to focus on today. So I'm looking for a magic number so that I can have opposite coefficients. So I either need a 1 and a -1 or a 3 and a -3 here. So I'm going to try to eliminate my x variable first. So I'm going to multiply this entire equation on bottom by a -3, and that will allow me to have a 3 and a -3, which will cancel out my x values. So I'm keeping my top one as y equals 3x plus 4. That's going to stay the same. The second equation, I'm going to multiply everything by -3. So -3 times y becomes -3y. -3 times x becomes -3x. And -3 times -2 becomes a +6. Now you'll notice that everything is lined up exactly. My equals is lined up, my y's, my x's, and my constants. So I'm going to add these two equations together. 1 minus 3 is -2y. 3 minus 3 is 0. And 4 plus 6 is 10. So I end up with this really simple equation of -2y is equal to 10. I can divide by -2, and I get that y is equal to -5. So now I found one part of this solution. I know what y is. So let's plug in y into one of these equations and find x. So I'm going to put it into the first one. -5 is equal to 3x plus 4. I'm going to subtract 4. I get -9 is equal to 3x. I'm going to divide by 3, and I find that x is equal to -3. So my ordered pair that I found here, x is equal to -3, y is equal to -5. I just need to check and make sure that both conditions have been met. So in the first one, -5 is equal to 3 times -3 plus 4. That's going to be -9 plus 4, which is -5. And then down here, I should have -5 is equal to -3 minus 2. -3 minus 2 is equal to -5. So both conditions have been met. So the correct solution for this is -3, -5. Now, we're going to do another example. This time, these are not already pre-set up for a substitution method, so I see this as being a great opportunity to do elimination method, where I can eliminate either the x or the y. It doesn't matter which one. So I either need a 1x and a -1x, or a 4y and a -4y. To me, I see the 4 first, so I'm going to go ahead and multiply by a +4 here. So on top, I'm keeping the original equation. On bottom, it becomes 4x minus 4y is equal to 12. Don't forget that the 4 also has to multiply by that constant over there. It has to be multiplied by everything. So I notice that my x's are lined up, my y's, my equal, and my constant, so I'm going to add everything together. 1x and 4x becomes 5x. 4x and 4y and -4y becomes 0, and 13 and 12 becomes 25. Then I can solve for this one variable, and I get x is equal to 5. Once I know what one of the the values is, I can plug it into the equation, top or bottom, and find the other variable. So 5 plus 4y is equal to 13. I can subtract the 5. I get 4y is equal to 8. And I can divide by 4 to get y is equal to 2. So my ordered pair here that I found is 5, 2. X is 5, y is 2. Let's check to make sure both conditions have been met. So 5 plus 4 multiplied by 2 is supposed to be 13. 5 plus 8 is 13, so that works. Then we have 5 minus 2 is supposed to be 3, and it is, so both conditions have been met. So 5 is x, and y is 2. And that's going to be our solution for this problem. Now we can look down here. On this one, we have a 3 and a 3, and we have a -10 and a -9. So I can do this a couple of different ways. I can make this a 3 and a -3 and multiply this by -1, or I can try to get these two together, and I can multiply this by a -9 and multiply this by a +10, and I can cancel these out with a 90. To me, the easier one here would be to multiply everything here by -1. So the first one says 3x minus 10y is equal to 14. The second one becomes negative 3x plus 9y is equal to negative 15. And then x's, y's, and constants are all lined up, so I'm going to add this together. I get 3 plus negative 3 is 0. Negative 10 plus 9 is negative y. And 14 minus 15 is negative 1. So I end up dividing by negative 1 and getting that y is equal to 1. Once I have that value, I can plug it into either equation. So 3 times x minus 10 times 1 is equal to 14. I can simplify, add the 10, and I get 3x is equal to 24, divide by 3, and x is equal to 8. So I find that x is 8 and y is 1. Let's double check and make sure that all conditions have been met. So 3 times 8 minus 10 times 1 is supposed to be 14, so that's 24 minus 10, that's definitely 14. And then 3 times 8 minus 9 times 1 is supposed to be 15, so 24 minus 9, that's 15. So both conditions have been met here. X is 8, y is 1. Okay, one more example. Again, we need to get opposite coefficients here. So I have a 4 and a negative 2, and I have a 2 and a 2. I need a 4 and a negative 4, or a 2 and a negative 2. So I could multiply this bottom one by either a positive 2 to get these to cancel out, or a negative 1 to get these to cancel out. Either way, it doesn't really matter. We just need to pick a direction. So I'm going to multiply this by a positive 2. So on the top, I have 4x plus 2y is equal to 6. On the bottom, I have negative 4x plus 4y is equal to 36. And then I'm going to add these together. 4 and negative 4 is 0. 2 and 4 is 6y. 6 and 36 becomes 42. I'm going to divide by 6, and I get that y is 7. Once I know what that y is, I can plug it into either equation to find x. So 4x plus 2 multiplied by 7 is 6. 4x plus 14 is 6. I'm going to subtract the 14. I get 4x is equal to negative 8. I divide by 4, and I find that x is equal to negative 2. So x is negative 2, y is 7 is my ordered pair here that I'm working with. Try to make that a little clearer. It's a negative 2. I just need to make sure that both conditions have been met. So 4 times negative 2 plus 2 times 7 is supposed to equal 6. That's negative 8 plus 14. That equals 6. And then the other condition is that negative 2 times negative 2 plus 2 times 7 is supposed to equal 18. So that's 4 and 14, and that does equal 18. So both conditions have been met. Alright, one final question. Let's look at a word problem that does have a solution this time. Okay, so we're working with Aaron and Adam, and they both have found this relationship between jelly and peanut butter, and we find that Aaron buys 4 jars of jelly and 6 jars of peanut butter for $19.32. Adam buys 3 jars of jelly and 5 jars of peanut butter for $15.67, and we're asked to find the cost of a jar of peanut butter. So what we don't know here, we know how many they purchased, we don't know what the cost per jar is. So I'm going to call X equal to the cost of 1 jar of jelly, and I'm going to call Y the cost of 1 jar of peanut butter. Okay. Now I know that 4 X's, 4 jelly jars, and 6 peanut butter jars, Y's, totaled $19.32 for Aaron. I also know that 3 jars of jelly and 5 jars of peanut butter totaled $15.67 for Adam. So that creates my two equations. Now, I can do this however I want to, but I'm going to do elimination method on this rather than trying to subtract one of these and then divide by a coefficient. It gets kind of messy at that point. So I'm going to try to do a magic number here. And in this case, I can't do just one magic number to get opposite coefficients. I'm going to need 2. So what I'm going to do is I'm going to multiply this equation by 3, and I'm going to multiply this one by negative 4. And what that allows me to do here is to get a 12 and a negative 12 for my x, and it will get rid of that, and I can focus on my y value. So I'm going to multiply these both out, and I get 12x plus 18y is equal to, let me grab my calculator and do 19.32 times 3, which is 5796. And then down here, negative 12x and negative 20y is going to total, let's see, 1567 times negative 4 is negative 62.68. And now I'm going to add these two equations together. So 12 and negative 12 becomes 0. 18 and negative 20y becomes negative 2y. And then the 57.96 minus 62.68 becomes a negative 4.72. I divide by the negative 2, and I get that y is equal to $2.36. Now, once I found that y value, I can plug it back in to find x. But in this case, the question is asking me for the cost of a jar of peanut butter. So I could stop right here.